fixed point. But before we talk about fixed point, I want to mention floating point, because you all heard of floating point numbers. They're the real numbers that have decimal points in them. They're the things you see on your calculator. But I do want to say it's beyond the scope of this course to go into the great detail that floating point requires for complete understanding. Computers use floating point to represent real numbers, and it's a trade-off between how much precision you get. The more digits, the more precision. But then if you want a big range of numbers, like you want to count into the trillions, you would need a whole lot of digits. But look at your calculator. You typically see 8, 10, 12 digits on the display, and after that they use exponents, because usually when you have billions or trillions, you're not concerned about a trillion plus 1 or plus 2. You're just concerned about, is it 1.67 trillion or 1.68 trillion, plus or minus a couple 100,000 or a million in the trillions is not that significant. So the trade-off is the more precision that you have less range. And the more range you have to represent big and small numbers, you have less precision. And that's because the exponent and the mantissa part of the digits are shared within a fixed number of bits. The IEEE 754 is a standard for 32-bit, 64-bit, 128, 256, and 40 and 80-bit formats of floating point numbers. But like I said, floating point numbers could be a whole Udemy course in itself on this. Okay, fixed point is fast and it's easy. And if you're using a small microprocessor that doesn't support floating point, you can make your own fixed point numbers. Like say you want to add up dollars and cents. Would you use floating point, or would you just arbitrarily fix the last 2 digits to be in cents, or think of all the prices you add up just being in cents? You want to add $1, you add 100 cents to it. You add everything up in cents, and then when it comes time to display it, then you could either take the string of digits and just output all but the last 2 and a decimal point and then the cents, or you could actually do the divide by 100 or whatever. It's a simple solution without using floating point, and it's fast and it's accurate, unless you're dealing with gas prices that use a fraction of a penny. Why they have that today, I don't know. So fixed point is used in digital signal processors. Sometimes you'll see a 32-bit fixed point number called a 16.16, where 16 bits are reserved for the whole part of the number and 16 bits for the fraction of the number. Other formats that could add to 32, you could split that 32 by 24.8 or 20.12 or whatever you need to get the digital signal processing job done. So sometimes you should consider using fixed point in some of your smaller microprocessor projects.